Okay. So again, so if you have several source charges Q1, Q2, Q3, and Q4, and so on, in order to get the total or the net force that this charges exerts on a test charge Q, you just have to account the individual forces that, say for example, Q1 exerts on Q, and then Q2 exerts on Q, Q3 exerts on Q, and then after that, you will have to take the vector sum of the individual forces. Okay? So now the force on Q depends not only on the separation distance r between the charges. Take note that r here, this one is equal to r minus r prime. Okay? So it is the distance between the source charge and the test charge. It also depends on both their velocities and on the acceleration of Q. Moreover, electromagnetic fields travels at the speed of light. So the position, velocity, and acceleration that Q had at some earlier time affect the force at present. Okay, so since this one, kini siya, no, if the charges are moving, medyo complicated because it will be dependent also, ang ilang force will be dependent on the speed of light or their speed, ang ilang position, ang ilang velocity and acceleration. Okay, so to begin with, we will consider a special case, which is the electrostatics, wherein we will take all the source charges as stationary, and the test charge can be moving. Okay, so in electrostatics, we will be considering all the source charges to be stationary or immovable. Okay, so we have Coulomb's law. Coulomb's law states that the force on a test charge Q due to a single point charge Q, which is at rest, a distance r away, is given by this equation. Okay, so you have 1 over 4 pi epsilon naught Q times Q. So Q here is the source charge, and then this big Q is the test charge over the separation distance squared r hat. So as you can see, it is a vector quantity force. Any type of force, including electrostatic force, is a vector quantity. So you have the direction. You have to specify a direction. All right. So note or recall that the separation vector is equal to r minus r prime. So this is your r. The distance from this one is the observation point, or pwede siya natatawagan as the origin towards the field point or the test charge. And then you have from here up to the source charge is r prime. Okay, so this one is a vector, the vector difference between r and r prime. So r minus r prime, that is your separation vector r. And then take note that this is a constant. Epsilon naught is a constant, which is equal to 8.85 times 10 to the minus 12 coulomb squared per Newton meter squared. So it is called the permittivity of free space. Okay. So this one, you have two glass rods. Both are positively charged. Okay, so they are repulsive, or they are exerting repulsive forces towards each other. So they are like pushing each other away. Okay, so the force exerted by this glass rod towards this glass rod is padulong dito away. And then kini po siya ga-exert po siya equal amount of force but is in opposite direction. So padulong diri. Okay, so even electrostatic forces are governed by Newton's third law of motion, the law of action and reaction. Okay, and then we have this one. You have another glass rod here that is negatively charged, and then ang isa kay positively charged. So they exert attractive forces towards each other. So kini siya, ang iyang gi-exert nga force is padulong sa iya. And then kini pod siya class, ang iyang gi-exert nga force is towards kini siya, towards niya. Okay, so they are pulling each other together. But take note also that they are exerting the same amount of force, the same magnitude, pero opposite ang direction. Okay? Now, the electric field. So, unsa man ang electric field? So again, Q is repulsive. I mean, F is repulsive if Q and Q have the same sign. So kung pareha sila positively charged or pareha po sila negatively charged. And then they are attractive if Q and Q have opposite signs. Okay? So we have here a question. How does one particle sense the presence of the other? Okay, so as you can see, yun siya class, no? The electrostatic force is an action at a distance force. So it is a non-contact force. So bisag wala sila physical contact, they can act or charge objects, charge particles can act to another charged particle. Okay, so how can one particle sense the presence of the other? No? Okay, so electric charge creates an electric field. So all electric charges emanates electric field. It somehow modify the space around it. So kung naay electric charge sa space class, it somehow modifies its surrounding. Okay? So a second charge particle does not interact directly with the first. Rather, it responds to whatever field it encounters. So in this sense, the field acts as an intermediary. Okay, so you have the electric field. So again, tanang charged object kay mo emanate siya og electric field which somehow modifies the space around it. Okay, and then if you have another charged particle, it can somehow sense the presence of mura siya ang electric field kay mura siya og aura sa imong electric charge. Okay, so kung mo-emanate siya og aura, like for example, kung naay another charge present in that particular space or near it, iya tong ma-sense iyang aura. Okay, so it will act, or the electric field will act as an intermediary between the two charges. Okay, now if we have several point charges Q1, Q2, and so on at distances R1, R2, so on from Q. the total force on Q is evidently equal to this one, okay? By virtue of the superposition principle, you have the total force is equal to F1 plus F2 plus that. So this is equal to 1 over 4 pi epsilon naught multiplied by Q1 times Q over R sub 1 squared, R hat, R1 hat, plus Q2 multiplied by Q over, you have this one, R sub 2 squared, R sub 2 hat, and so on. Okay? Now, you can actually take Q out. So, since Q is common to all terms here, so bisan pagpila ni siya ka terms, na siya Q. Okay, so we can take Q out of the parenthesis. So you have Q over 4 pi epsilon naught, and then what is left inside the parenthesis are these terms. Okay. Now, kini siya class, kini siya nga term, Q1 over R1 squared R1 hat multiplied by 1 over 4 pi epsilon naught. We can call that electric field 1. And then this one also, Q2 over 4 pi epsilon naught R sub 2 squared R hat, that is E sub 2, okay? And so on. Okay, so we can generalize this expression as F equals Q times the electric field. Okay, so in general, the electric field is equal to 1 over 4 pi epsilon naught. This is the total electric field sa point charge, sa source charge or test charge, big Q. So you have 1 over 4 pi epsilon naught multiplied by the sum of all this. So naakay Q sub I over R sub I squared, R sub I hat. Okay? So that is the electric field. So force is equal to Q times the electric field. So the electric field E, ang electric field class is denoted by the capital letter E. Okay? So physically, ang meaning sa electric field is the force per unit charge. So when you manipulate this equation, you can see that the electric field is the ratio of the force and the charge Q, the test charge Q. Okay, so it is force per unit charge. So if force has units of Newton, then electric field has units of newtons per coulomb. Okay? Now notice that it is a function of the position R because the separation vectors R depend on the location of the field point P. Okay, so you have this one. Suppose you want to know the electric field at this point. So we can call this the field point. And then we have here several source points. Now, by virtue of the superposition principle for electric field, you can also get first the individual electric fields due to the individual charges. Okay, so for example, electric field 1, E sub 1 due to Q1 is equal to 1 over 4 pi epsilon naught Q1 over R sub 1 squared, R sub 1 hat. Okay? And then, kuha na po dato ang electric field at this point due to Q2. And i-add lang din to nato itong mga individual electric fields. Okay? So that is the total field at point P. Now, take note that it is vector addition because electric field is a vector quantity. So, like force, electric field is a vector quantity. Okay. So, dapat kinani siya mga examples kas. But we will have those examples sa next meeting class. We will have our exam. Okay, so we will have our exam. So we will meet on Monday for examples. Hopefully, I will be able to wake up early para makaadto pwede ko sa office class. Naman ko dito ako ang pen tablet. Okay. So, how about for continuous charge distribution? So, kini siya na kay mga individual source charges. But for continuous charge distribution, for example, if you have this one. Okay. So, this is a charge surface. Okay. So, if the charge is distributed continuously over some region, so this is a region of continuous charge distribution, the sum becomes an integral. Okay, so di ba kaganina, you have this one, the electric field is expressed as the sum of Qi's over R sub I squared. So if the charge is distributed continuously over some region, such as this one, the sum becomes an integral. Okay, so you have E of R, E as a function of the position is equal to 1 over 4 pi epsilon naught multiplied by the integral of 1 over R squared, R hat, you have here dq. Okay, so dq here is this one. So you just have to get a very small portion of the region. So say for example, kung kini siya nga region class kay na siya total charge nga Q, and then magkuha lang ka gamay nga portion. So that portion or that particular area aning a region has a charge equal to dq. So we can call this infinitesimal charge dq. Okay, so if we want to know the electric field at this point P, we can call this the field point P. Okay, so we can just take the integral. So na kay 1 over 4 pi epsilon naught multiplied by the integral of 1 over R squared R hat dq. Okay, now if the charge is spread out along a line, so say for example, you have a charged rod, for example. So the charge is spread out along a line, such as this one. So we define the charge per unit length lambda, wherein kaning imong dq diri, small charge, infinitesimal charge dq, it is equal to lambda times dl. Okay, so dq here, kining equation can be replaced by lambda times dl, where lambda is the charge per unit length. Okay, so the equation now, this equation now will become this one. So you have 1 over 4 pi epsilon naught integral of lambda dl over R squared R hat. And then if the charge is smeared out over a surface such as this one, so na kay surface, no? So magkuha kag surface element diri dA, then napo tayo gitawag na charge per unit area sigma, denoted by sigma. So you have your dq is equal to sigma over dA, or sigma is equal to dq over dA. Okay, so from this equation, we can replace it with sigma times dA. All right, and if you have a volume, so if you have a volume charge distribution, or if you have a volume that is filled with charges, then we can define the charge per unit volume rho. So you have dq is equal to rho d tau. Okay, so we know dl in Cartesian, in cylindrical, and in spherical coordinates, as well as dA and d tau. All right, so you have for volume charge, you have 1 over 4 pi epsilon naught multiplied by the integral of rho d tau over r squared. You have r hat here. Okay, so na siya note, no? Please note carefully the meaning of the position r in this formula. So, kini nga mga r. Okay, so originally, r stood for the vector from the source charge Q1, Qi to the field point r. Correspondingly, r is the vector from dq. So, r is the vector from dq to the field point r. So, therefore, from dl, dA, or d tau. So, gikan diri from dq padulong sa imong field point. So, muna siya si r. Okay. So, we have here a problem. Okay, so let us take a look at this problem, class. Yes. So find the electric field at distance z from the center of a spherical surface of radius r, which carries a uniform surface charge density sigma. Okay, so we are given with a spherical surface of radius r, and we want to know the electric field at distance z from the center. Okay, so we have here the illustration. So this is the sphere, and then you have x, y, and z. So we want to know the electric field at distance z gikan diri sa center sa imong spherical surface. All right. Now take note that any point diri sa imong surface, ang ang distance gikan sa center class kay kining big R, the radius R. Okay. Now, we have this equation. So what we know is this equation. If you have a surface distribution, so you have 1 over 4 pi epsilon naught integral of sigma dA over r squared r hat. Okay, so dq, so kini si sigma dA class, this is actually equal to dq, right? So kini siya dq. So dq is equal to sigma dA, and your dA in spherical coordinate is equal to r squared sine theta d theta d phi. Okay, so I hope you can recall this one from our previous lessons. Okay, so you have sigma multiplied by r squared sine theta d theta d phi. And then our r squared here, class, is the magnitude of the separation vector squared. And we can get this by, so ang ganun siya pagkuha. You have here your r, muna siya inyong r, and then you have your theta here. So we can get this by the cosine law. So you have r squared plus z squared minus, kung nakadumdum pa mo sa cosine law, you have a squared plus b squared minus 2ab cosine theta. So you have here r squared plus c squared minus 2rz cosine theta. So r is the distance from the origin towards any point sa surface. So diri siya nagkuha og surface element, no? dA, diri siya nagkuha og surface element dA. So gikan diri padulong sa surface, ang distance ana niya kay r. Okay, equivalent to the radius of the sphere. And then, kini siya nga side, padulong sa point, is equal to z. So, a distance z from the center. So, muna siya ang distance from the center towards the field point. So, your r is equal to, meaning the separation vector can be obtained using, the cosine law. Now, here, the only component sa ato ang electric field class is kani, E sub Z. Okay? So, you have your E sub Z. So, as you can see, it is adjacent to angle theta. Antay pang sulat class, no? Alright. Okay, so you have this one. E Z. So, this one, kini siya class, kini imo ang ER. This can be simplified. Okay, so mahimo na lang siyang E sub Z. So, you have the Z component of the electric field, which is equal to this one. So, you have the magnitude of ER multiplied by cosine of this angle sigma. So, here you have sigma. So, this is theta, and then we define here another angle sigma, which is, kini siya nga side is adjacent to your angle sigma. Okay? Now, we can get cosine sigma here. Okay, so saan ni siya na to pagkuha si cosine sigma? Yun saan niya pagkuha, be? Cosine sigma is equal to the adjacent side over r, the hypotenuse. Okay, so you have here, nganong z minus r cosine theta man ni siya. How many r cosine theta class? If this is r, if this is r here, r cosine theta is along this one. Naa siya diri no, along the, naa siya sa xy plane. So your r cosine theta is in the xy plane. Okay. So this is your r cosine theta. Dili ko ka-drawing. Okay, so this one. This is your r cosine theta. And then this is your z. So z minus r cosine theta over r. So that is your cosine phi. Phi man no? Okay. So substituting this into our equation. So the magnitude of ER na kay 1 over 4 pi epsilon naught multiplied by the integral of sigma r squared sine theta d theta over r squared. So your r squared is r squared plus z squared minus 2rc cosine theta. And then multiply this with cosine of this angle. So it is equal to z minus r cosine theta over r. So you have your r here. Pwede siya na to i-appeal, ani no? So r, the magnitude of r is equal to the square root of this. So it is equal to the square root of this one, square root of r squared plus z squared minus 2rz cosine theta. So in the denominator, you have this factor raised to 3 halves. Okay? So because you have na kay r squared daan tapos 1 half, so you have 3 halves. All right? So we can actually take some of the constants out of the integral. So what are these constants? Naakay r squared sigma. So pwede siya na ito mapagawa sa integral sign. And then, if you integrate d phi, you will get 2 pi. So, nasolve na siya na ito, no? So, pwede na ito ipagawas daan si 2 pi, and what is left is this one. So, the ones that are dependent on theta. So, you have z minus r cosine theta sine theta over r squared plus z squared minus 2rz cosine theta raised to the power of 3 halves. Okay, so this is a very complicated integral. So, atong buhaton is mag-change ta og variable. So, let u be equal to cosine theta so that du is equal to negative sine theta d theta. And then, since nag-change man ta, nag-shift ta og variable, we will also shift limits. Okay, so theta equals 0, u is equal to positive 1. And then, if theta equals pi, then u is equal to negative 1. So, from 1 to negative 1. Okay, so you have 1 over 4 pi epsilon naught 2 pi r squared sigma. And then, mas maayos ang tatog masulat na takas, no? Okay, so naakay, nag-change man tag variable. So you have, iyan ang gi-evaluate diretso ka. So I think, pag change aning variable, pwede na dahil ni siya na to gamitan og integral table. So, the integral of this very complicated integral is equal to this one. 1 over z squared multiplied by z u minus r over the square root of r squared plus z squared minus 2 r z u. Okay? And this is from negative 1 to 1. So, nag-shift ta og limit. Nag-shift ta og limit. Supposedly, it's from 1 to negative 1. So, I think nani siya negative sign diri but since nag-shift ta og limit, negative 1 to 1, nawala ang negative sign. Okay? So, if we further simplify this one, we will have ano siya nga term. Okay? So, if z is greater than r, meaning to say na siya sa gawas sa spherical surface, or yeah, it is outside the sphere, then E sub z is equal to 1 over 4 pi epsilon naught 4 pi r squared sigma over z squared. Okay, so unsa mahitabo? If z is greater than r, z greater than r. So, kini siya nga term diri kay mahimo siyang 2. Okay? So, you have 1 over 4 pi epsilon naught 4 pi r squared sigma over z squared. And then, if z is less than r, or if it is inside the sphere, kung nasa diri for example, then your E sub z is equal to 0. So, walay electric field inside. If your field point is inside the sphere, the electric field is equal to 0. Okay? So, this term here will become 0. So, multiplying this to this, you will get 0. Okay? But we can simplify this. Kini siya nga solution class. This can be simplified using Gauss law. Okay, so this is a very long integration. Kung wala ka nakabalo sa integral table, pwede ba na siya makasearch naman ka sa internet o kato mga integral tables class. So kung di ka kabalo ato, this will be very, very long. But you can use Gauss law to make it simple. Okay, so I guess the next ang next na topic kay Gauss law. Okay, do you have any questions so far? Someone is... Okay, any questions, class? Okay, so we will have another example next meeting, no? Okay, so far, ma'am, wala kay ko nakasabot. Mas better tong isulat-sulat pa ni mo, ma'am, lagi. So, kung problem, dapat isulat gyud siya. Sige lang, magsulat data. Okay, so let's proceed to section 2. So, summoning section 2. So, divergence and curl of electrostatic fields. So again, i-discuss lang ni siya na to ha, and then balik din ta diri next meeting when we will have our lecture class, we will go back to some examples. Okay, so daghan tayong example nga i-solve. So i-discuss lang na to ning concept. All right. So you have divergence and curl of electrostatic field. So you might have noticed wa man dito assignment pa no. The integrals involved in computing the electric field can be formidable. So in the next discussion, so kaning atong discussion karon, we'll be learning tools in order to avoid these integrals. Okay, so we will learn Gauss law. Okay, so for field lines, we define field lines as these are field lines. We can call this field lines, and it represents the direction of the electric field. So as you can see, you have a positively charged particle here and then a negatively charged particle nearby. So the electric field lines goes out from a positive charge. So it comes out from a positive charge and into a negative charge. Okay? So, muna siya ang direction sa electric field lines. Now, the magnitude of the field is indicated by the density of the field lines. So, for example, kani siya nga point, since daghan diring field lines imong makita, then we can say that intense ang electric field diri. Okay, so the electric field at this point is dako siya value compared to at this point. Kay lagyo man ang field lines. So again, the density of the field line indicates the magnitude of the electric field. So the denser is the field lines, the greater is the magnitude of the electric field at that point. Okay? So it's weak farther out where they are relatively far apart. So kini siya lagyo man ang electric field lines diri pod, then gamay ang magnitude sa electric field at this point. Okay? Again, the electric field lines begin on positive charges and end on negative ones. So, kaning arrow diri indicates this. So, it comes out from a positive charge and it goes into a negative charge. Now, they cannot simply terminate in midair, though they may extend out to infinity. And also, they can never cross. So, these are the properties of electric field lines. They can never cross, they cannot simply terminate in midair, and they can extend to infinity. Okay? Now, we define the electric flux. Unsa ni siya nga kuan class? Greek letter phi, which is equal to the integral of E dot dA. So you have here E, the electric field, and then you have here another vector, the area vector dA. So you get the dot product of these two and then take the integral over all the surface. So that is the electric flux, or we can call it the field flux or the electric flux. So it is defined, or it is physically defined as the number of field lines passing through a given surface. Okay, so for example, you have this surface, and then kini siya nga surface is in an electric field region. So ibutang siya nimo sa region with electric field. So naay mo pass through diri nga mga electric field lines. So the flux is defined as the number of electric field lines passing through a given surface. Okay. Now, the area vector, kini si dA class, we define the area vector as a vector that is perpendicular to the area or the surface. So if you have a surface that is directed vertically or is oriented vertically, then ang imuang area vector is na horizontal. Either padulong sa east or west, or depende kung unsay orientation sa imuang surface, but it is always perpendicular to the surface. Now, the number of field lines is proportional to the magnitude of the charge. Okay, so depende dahil siya sa magnitude sa inyong charge. So, for example, na kay charge Q, and then applicate another charge 2Q. Okay, so the greater the magnitude of your charge, mas mudaghan pod ang number sa iyang field lines. Okay, so kato si 2Q, mas daghan siya og electric field lines compared sa charge Q. Alright, so therefore, this suggests that the flux through any closed surface is a measure of the total charge inside. So the flux through any closed surface is a measure of the total charge inside. So this is the essence of Gauss' law. So let us continue. Okay. Now, in the case of a point charge Q at the origin, the flux of E through a sphere of radius r can be expressed as this. So, okay, electric flux is equal to the closed integral of E dot dA. And we know that for a point charge, ang iyang electric field class is equal to this one. 1 over 4 pi epsilon naught Q over r squared r hat. And then, your dA for a spherical surface is equal to this one. R squared sine theta d theta d phi r hat. Okay? So, if we evaluate this one, overall space So, what will we get? So, pwede na ito ipagawas daan si 1 over 4 pi epsilon naught. And then, the radius also, I guess we can take this out of the integral sign because constant or mawala man po niya siya diri ka sa r squared divided by r squared. So, mawala ni r. Okay. And then, we will evaluate sine theta d theta and also d phi. We know that d phi is equal to 2 pi, right? Integral of d phi is equal to 2 pi. So, yan, nakay 2 pi diri. And then, sine theta d theta, integrating this, you will get, so integral of sine theta, what is the integral? Excuse me. Let's go to again. Okay, so if we get the integral, the integral of sine theta d theta, you will get, so cosine theta evaluated from 0 to pi, so we'll get 2. Okay, so nakay 4 pi. From here, the integral of, kini siya no, nakay makuha diri nga 4 pi, 4 pi. So, so nakay 1 over 4 pi epsilon naught times q, since r squared has been cancelled out. And then here nakay 4 pi, so if you multiply that, you will get q over epsilon naught. So the flux through any surface, including the charge, is actually q over epsilon naught. So dili lang ni siya limited sa sphere of radius r, but for any closed surface, the flux through any surface enclosing the charge is equal to q divided by epsilon naught. Okay? Yeah, you have questions?
Dili na siya ma-negative, ma'am, kay ang integral man sa sin theta kay negative cosine.
Yeah, it's negative cosine theta. So you have, sakto ba, negative cosine theta? So negative cosine pi minus negative cosine 0. So yun na. Negative 2 ang answer. Di ba na-solve na siya to?
Medyo naputol ka dili sa ako, ma'am, do. Pero saan nawala ang negative sign, ma'am?
Okay, so you have the integral of sine theta is negative cosine theta. And then, nato siyang evaluate with from 0 to pi. Pi ba to or 2 pi? Theta is from 0 to pi, right? Yeah, it's 0 to pi. So, naakay negative cosine 180 degrees minus negative cosine 0. So, you will get 2. I-try ganin ninyo, negative cosine 180 degrees because that is pi. Cosine 180 degrees is negative 1, and then naman kay negative sign, so you have negative of negative 1, so that is 1, minus negative cosine 0. So that is also plus 1. So you have 2. Okay?
Oh, yes,
So,
ma'am.
okay. So, kini siya, the integral of sine theta d theta d phi, you will get positive 4 pi. Okay? So, again, the flux through any surface enclosing the charge is equal to Q over epsilon naught. Now, suppose a bunch of charges are scattered about. So, naay mga other charges. So, kini kay point charge pa man ni siya class. Okay, so how about if we have a bunch of charges? Okay, so according to the principle of superposition, the total field is the vector sum of all the individual fields. So you have this one. Okay. Sorry. Okay, so the flux, we can get this using this equation, E dot dA. So the flux is equal to the integral, the closed integral of E dot dA. And since E is the sum of the individual electric fields, so you can have this expression. So summation of E ice dot dA equal to summation of 1 over epsilon naught Q sub I. So you have here, kini siya class, if you get the individual fluxes sa imo ang itong closed na surface, no? So, it is just like, kwaon nimo siya tagsa-tagsa and then isum up. Or, it is just the same as, you sum up all the Q over epsilon naughts, no? So, isum up lang nato tanang Q over epsilon naught. So, for example, na kay Q1, Q2, Q3, and Q4. So, you have Q1 over epsilon naught plus Q2 over epsilon naught plus Q3 over epsilon naught. So, ano gyapon ang concept? Parehas sa superposition. Or, in other words, we can generalize this using this equation. So, the closed integral of E dot dA is equal to all the enclosed charge over epsilon naught. Okay, so you can just add all the enclosed charges, Q1 plus Q2 plus Q3 and so on, and then divide that with epsilon naught, so that is the flux. Okay, and that is actually Gauss law. All right, so Gauss law. Okay. So, muna siya si Gauss law, class. So, take note of this. This is Gauss law in integral form. And then, if we apply the divergence theorem, dumdum pa mo sa divergence theorem, according to the divergence theorem, E dot dA, the integral, the closed integral of E dot dA over all the surface is actually equal to the volume integral of the divergence of the electric field, or the divergence of any vector integrated over the volume. Okay? Sorry. Now, noting also that, excuse me, guys. Noting also that Q enclosed is equal to, we can actually express Q enclosed as the integral of rho d tau. So, hanin siya gikan class katong kaganina, no? Volume charge density. So, you can get the total charge here by integrating this. Okay, so, if you want to get the total charge Q, you will integrate this one. So, you have integral of rho d tau. Your rho d tau is equal to the total charge, or the Q enclosed. So, you have this one. Q enclosed is equal to the integral of rho d tau. Now, so kini siyang equation, the left-hand side of the equation, we will replace it with the volume integral. So you have the volume integral of the divergence of E times d tau is equal to, kini po siya, the right-hand side of the equation. We will replace Q enclosed with this. Okay? So you have the integral of rho d tau over epsilon naught. Okay, so therefore, we can say, so pareha naman sila no, volume integral na kay d tau diri, d tau also diri. Then, meaning to say, kini dahil sa class, the divergence of E is actually equal to this one. So, equal lang ni sila. Two integrals are equal if, pareha ni sila no? Equal ni sila. Okay, therefore, we can deduce that the divergence of E is equal to rho over epsilon naught. So this is Gauss' law in differential form. So Gauss' law in integral form, and you have here Gauss' law in differential form. So this is one of the four Maxwell's equations. So Gauss' law in differential form. So nanatay na ilhan nga isa ka equation sa Maxwell's equation class. Okay? So this is one of the four Maxwell's equations. Okay. So actually class kay ako'y klase pod karon 8:30 but dili na nako mapas kung maligo pa ko. I will arrange another online discussion for them also. I hope they will be okay with it. Okay, so let us continue with the divergence of E. The divergence of E. Okay, so calculating directly the divergence of E from Coulomb's law. So you have, this is the electric field, 1 over 4 pi epsilon naught multiplied by the integral, the volume integral of rho d tau over r squared. So this is the divergence in terms of r. So since r dependence is contained in kini siya nga r class, kini siya nga r, which is equal to r minus r prime, we have, I guess, kining r nga iyang gimin diri, this is this r, kini siya nga r, kining separation vector. So as you can see, pareha siya expression sa separation vector. And then wala jud ko nakakita og any r diri nga term. So ang iyang gimin diri nga r is this one, the separation vector r. So we have the divergence of E is equal to 1 over 4 pi integral of the divergence of, oh, this is familiar. Kini siya nga term class is familiar. So r hat over r squared multiplied by rho d tau. Now we know from our previous discussions that the divergence of r hat over r squared is just equal to 4 pi times the Dirac delta function, the three-dimensional Dirac delta function. Therefore, we can write this, kini siya nga expression, as 1 over 4 pi multiplied by the integral of 4 pi times the Dirac delta function times rho d tau. Okay? And then according to our previous slide, kini siya class is just equal to rho over epsilon naught. Okay? Pareha sila no? Pareha tag nakuha kay ngano ganing mahimo ni siyang rho over epsilon naught. This one has a value only for r equal to r prime. Okay, so kay 4 pi, you can take this out of the integral sign. So we can cancel 4 pi out. So ang mahabilin diri is 1 over epsilon naught. And then, si Dirac delta function, this is equal to 1 if, sa ganito class, if R is equal to R prime. So what is left here is kani. Kini nilay nabilin. So integral of rho d tau. And then you have 1 over epsilon naught outside. Okay. Okay. So from the divergence theorem, we have obtained this one. And then from here, from Coulomb's law, we have also obtained this. So Gauss' law in differential form. Okay, so we have here applications of Gauss' law. We have 10 minutes, 11 minutes left. So how can we apply Gauss' law? So, kaganina kung nakadumdum mo class, natay gisolve nga problem no, na siya gisolve nga problem 2.7, and we have encountered long integration or gabi ka lisod nga integration. Okay, so using Gauss' law, we can use it to minimize those formidable integrations. Okay, so when symmetry permits, so take note that you can only use Gauss' law for symmetrical surfaces. So when symmetry permits, it is the quickest and easiest way of computing electric field. So as you can see here, murag pareha ni siya nga problem kaganina. Pareha ni siya nga problem kaganina. So find the field outside a uniformly charged solid sphere of radius r and total charge q. So remember the problem 2.7. So what you will do is you draw a spherical Gaussian surface with radius r that is greater than r because we want to know the field outside. So the spherical Gaussian surface that you should draw should have a radius that is greater than r. Okay, so kini siya no? Muna siya imo ang sphere with radius r, and then magdrawing ka o Gaussian surface, spherical Gaussian surface of radius that is greater than big R. Okay, and then using Gauss' law, you have this one. E dot dA is equal to Q enclosed over epsilon naught. Now, the electric field is constant, so you can take this out. The magnitude of the electric field is constant, so you can take it out of the integral sign. And then you're left only with dA here. Now, for a spherical surface, dA is equal to r squared sine theta d theta d phi. And we have already solved that. I do not know if na-solve na ba ni siya na ito. Murag na sa inyo ang problem set class. If you get the integral of dA for a spherical surface, you will get 4 pi r squared. So this is actually the surface area of the sphere. Okay, so kini si 4 pi r squared, this is the surface area of the Gaussian surface. Okay, and then you multiply this with E and equate it with Q over epsilon naught. So here you can get E equals 1 over 4 pi epsilon naught Q over r squared. So from here, you will get the electric field. So easy. No, so yun nakaayo, 1 over 4 pi epsilon naught Q over r squared. Where kini siya, or r is equal to z. Since we want to know the electric field at this point, z a distance z from the center. Okay, so we can replace this with kining r diri the distance between the source point and the field point is actually equal to z. Okay, so dali ra kay siya class kay ganina balikan to nato no murag makalipong kay nga equation. So you need to consider geometry, you need to know the integral of this, nag-change patag variable, nag-change patag limits. Okay? And then, ang atong nakuha kay kani, 1 over 4 pi epsilon naught q over z squared outside the sphere. And using Gauss' law, we have simplified the process. Kini ra tong gigamit ng equation E dot dA equals Q enclosed over epsilon naught. Tada. So, nakuha na to ang electric field. Okay? Now, Gauss' law is always true, but it is not always useful, especially for non-symmetrical surfaces. So, magamit lang nato si Gauss' law if we have this symmetry. Spherical symmetry. Okay? So, kung nakay point charge, pwede ka maghimo og spherical Gaussian. Kung napo kay spherical surface, pwede ka maghimo og concentric nga sphere na Gaussian surface. And then, for example, you can also use the cylindrical surface, a cylindrical symmetry. Okay, so for example, nakay wire, nakay rod, charge rod. And then you want to know the electric field at this point dool sa rod. So pwede ka magbuhat ana og cylindrical nga Gaussian surface because it has cylindrical symmetry. And then kung naapog kay plane, pwede ka magbuhat og Gaussian pillback such as this one. Okay, so again, Gauss' law is always true, but it is not always useful. So, kailangan og symmetry in order for us to apply Gauss' law. Okay, so malang po na ang limit ni Gauss' law, class. Okay, so here is another example. A long cylinder carrying a charge density that is proportional to the distance from the axis. Okay, so we are given with rho, the volume charge density of the cylinder equal to Ks for some constant K. All right, so here is your cylinder. And then, naa siya length L, and ang iyaang radius kay S. Okay, and then, for this, we can use Gauss' law to find the electric field at any point outside the cylinder. Okay, so magbuhat lang kag cylindrical Gaussian surface that has the same orientation as your cylinder. Okay. And then, so the first thing that we do is to find the enclosed charge by using this equation. So you have the integral of rho d tau. So rho is given, it is equal to Ks. And then d tau for cylindrical coordinates is equal to S ds d phi times dc. So you have, i-evaluate lang ni siya nato, no? K is constant, pwede na siya nato ipagawa sa integral sign. And then, you have here your d phi, integral of d phi is also equal to 2 pi. And then your dz, this is integrated from 0 to L. So, nakay L. So, you now have 2 pi kl. What is left is S squared ds. Okay, so nakay S squared ds. So, integrate lang ninyo mo si S squared ds. This is actually the radius S prime of the Gaussian surface. So, you have, so ano siya? S cube over 2. Ito ba? S cube over 2. S cube over 2. Over 3 rather. S cube over 3. Integrated from 0 to S. Okay, so ato siyang evaluate, you will get 2 pi 2/3 pi KL S cube. Okay? So, ano lang kadali ang Gauss law class. So, first, you get the enclosed charge. And then, here, you have E.dA, since E is constant, ani nga point class, or any point diri sa gawa sa imong sphere, E will not change. It is constant for the same value of S. So, pwede siya na ito ipagawa sa integral sign. And then, what is left is dA. Now, dA for a cylindrical surface is equal to 2 pi RL or 2 pi SL. So, this is actually the surface area of the sphere. Kini iyang body sa sphere. Now, supposedly, napa ni siya nga mga surfaces. Kini siya nga surface, kini siya nga surface. But, when you take the dot product of kining dA diri, na kay dA pagawas, na po kay dA diri pagawas, you will get 0. The flux here is equal to 0 because the electric field is going to kini pasaka or paubos, and then ang imong electric field, imong area vector diri kay pagawas, they are 90 degrees with respect to each other. Diri pod 90 degrees with respect to each other, so you will get 0. So supposedly you will consider 3 surfaces here. So surface kining body, and then kini po dayong mga taklob sa imong cylinder. Okay? But since the area vector is padulong dire, ang imong electric field kay padulong dito, they are 90 degrees with respect to each other. E.dA is equal to 0. Kini pod, the same with this one. Okay, so what is left is kining nga surface, kining sa body. So this one, ang dA diri is ang sa ganitong area class sa imong cylinder. Magkuha man kagamay nga infinitesimal area diri So unsa may dimension ani niya. So the dimension is saan kito pagkuha sa dA? Dapat makabalo mo ani ha. So kung magkuha ka diri og gamay nga area, iyang dimension kay R or S D phi times SD phi ba? SD phi times DC. So kining nga length DC to siya, tapos kani siya kining diri lisod kay kas nung kay dili ma-drawing. Okay? So yeah, ang constant ani kay S. I hope naka-remember pa mo ato unsa ang pagkuhag dA. And then kini siya nga area diri kay naa siya infinitesimal area DC, naa siya DC, dimension nga DC times SD phi. Okay? So naa kay dA is equal to SD phi times DC. And then if you integrate that one, you will get S times 2 pi times your DC is from 0 to L, so you have L here. So this is actually the area of the body of the cylinder. So as you can see, ang imong cylinder class, ang iyang dimension ana, kung imo ni siyang kung mag-ikat nimo ang cylinder, ang iyang body kay mura na siya rectangle. So mura na kag ang iyang length is equal to, or ang iyang width is equal to the circumference of the circle. Kani siya nga circle, muna siya 2 pi S. times the length of the cylinder. So, nakay 2 pi s times L. So, muna siya ang area sa imong body sa cylinder. Okay, I hope inyo siyang ma-imagine, class. So, you have this one. E dot dA is equal to E times 2 pi SL. And then, we will equate this one to Q enclosed over epsilon naught. So, E times 2 pi SL equals 1 over epsilon naught multiplied by our Q enclosed, which is equal to 2/3 pi KL S cubed. So, we have E equals this one. Okay? So, this is just this is a very easy way to solve for the electric field using Gauss law. All right, so do you have questions, class, before we end our discussion? So again, on Thursday, we will have a quiz or siguro magmuna to sa inyo ang midterm exam.
Ma'am, ang
Yes.
coverage, ma'am, from the
Chapter 1 ng tanan.
Okay, ma'am.
Okay, so please submit your problem set. Dili ni siya appeal sa midterm exam, Sheila. Ang chapter 2. Okay, so see you on Thursday, class.
Yes, ma'am. Ma'am, asan mo ipasa dito sa table?
Yeah, sa table lang.
Okay.
Dili lang sa G-class, Sheila, sa table lang. Table na ko. Okay, so bye-bye.
Thank you, ma'am.
Ma'am.
Thank you, ma'am.
Thank you, ma'am.